This is going to be the first workshop of a couple-part series. What we're going to do is we're going to first just cover Git and GitHub, which is part 1. So a quick who am I? Previously, I've worked in cybersecurity, chemical technologies, IT. I've been a programmer for over almost a decade now. But eventually I fell in love with psychology, realized that I wanted to help contribute to that field. But today I'll just be your teacher for Git and GitHub. Let's start from the top. What is Git? Git is a version control system. Kind of like a checkpoint system in video games. In a video game, you can make these save points, and imagine that you could go back to any one of these points in the past, or, look at what it is. That's the first job of Git. Now, when you make a folder that has this fancy checkpoint system, it's called a Git repository or a Git repo. On your computer, though, it's just a folder with some special files inside it. I'll show this off later, but that's really all it is. But if I say Git repo, just know it's one of those folders that's been marked as a Git repo by having another folder in it. So what else does Git do? The other job of Git is to handle the changes when more than one person is working on a file. So imagine you're working on a Word document, say how many days since the last psychology pun. Now you might be a fan of making sure that number stays very high or at 0. But let's say you send this to a friend, and they're of the opinion you should never make a psychology pun, so of course it's 4 days since the last psychology pun. However, you're of the other opinion, and so that day you in fact do make a psychology pun. But you made that change before your friend sent that document back to you. How do you combine those? I mean, this example's simple. You look at it and you change that number, right? But imagine there's like 1,000 lines to this document. Comparing and contrasting all those lines that may or may not have changed is a real pain, and Git can help do all of that for you, or at least holds your hand and says, here are the things that changed, which do you want to keep? I'm not going to be talking about this part today. This part's actually the second workshop, which is handling Git when there's more than one person involved. But I just wanted you to know this is the other main role of Git. So what's the difference between Git and GitHub? Git is kind of like Microsoft Word. It's just a program on your computer. Microsoft Word helps you to make Word documents on your computer, and Git helps you make Git repos on your computer and handle and deal with those Git repos. Now, sometimes you want to share a Word document with other people, so you use an online service to save and share it, like OneDrive or Google Drive. This is exactly what GitHub is. It's just an online service used to save or share Git repos. GitHub, Bitbucket, BitLab, those are all just the same fancy online storage services. But at the end of the day, that's all it is. So, what's the basic workflow to use Git? The first thing we're going to do is create a repo. What I'm going to say here is the left side is going to be the layman's version of this, so I'm just going to say it in plain words. And the right side, I'll say it in the technical way with the specific command at the end. I'm going to be doing this a lot of times over the course of this presentation. I'm really just trying to drill both versions into your brain and get you to connect them and get you to see these things. So first you're going to create the repo or initialize your repo with git init. You may also download a repo from GitHub to work on. This is called cloning the repo with git clone. Then you have to go and create or edit some files within your Git repo. After that, you'll select the files and folders for your new checkpoint, or you'll stage the files and folders with git add. Then you're going to make the new checkpoint, or make a commit with git commit. So step 3 is you have all your files, right? You pick which ones you're going to want to add to that checkpoint or commit. And then step 4 is you actually make the commit with those, because sometimes you don't want to add all of the files. The final step is you're going to upload that new checkpoint to GitHub, or you're going to push your changes to remote with git push. To clarify, when you push your changes, it means it's going from your computer to that cloud service or to somewhere else. And remote almost always means the other place where you're getting your info from. That usually means GitHub. It just means the online service. Then you just repeat steps 2 through 5 until the project is over and you're done. Quickly see some other commands. So first, you can check what files have been changed. So you'll check the status with git status. Next, you'll see your old checkpoints, or you can see your commits with git log. You can see the difference between two checkpoints, or you can see the diff, stands for difference, of two commits with git diff. You can also see the changes since your last checkpoint, or you can see your current changes with git diff. Git diff does both things. So you can download any newer changes that were online, or update your repo with git pull. So pull is when you go from the online to your local, and push is when you go from local to online. Here's a big command list of everything I just showed you. You don't have to read all of this. This is just here for your convenience when I post the presentation online so that you have it. Don't worry about reading or copying this. I'm just letting you know it's in there. I'm going to do a demo now. We're going to walk through this with the actual commands. On top of that, I'm also going to show it to you because of what Elle suggested with GitHub Desktop, so you can see what that is like. Here we are in our, I just have Visual Studio open. And what we're going to do is we're going to create a Git repository. That is done, or initialize a Git repository with git init. And now, you can't see it in here because it's a hidden file, quote unquote, which means it starts with a dot. But if I were to list, and then list everything, you can see there's actually another folder in here. I'm not going to go into what's in that folder or all the technicalities of that. Almost never do you need to know that, but just know it's there. And if there's ever a folder with this inside it, it's a Git repository. Once we initialize one, well, the first thing we have to do is make a file. So let's make a new file. We'll make a text file, and we'll call it test.txt. Right. Then I'm just going to put a 1, a 2, and a 3 in it. I'll save it. And then you can see it over here. Now the first thing we're going to do is type git status. This shows us what the status of it is. Now you can see there's test.txt, which is what we made, and it's called an untracked file. Untracked files are files that have never been recorded by Git before. It's Git telling you that I haven't watched this before, I'm not watching it yet, so just letting you know I'm not recording your changes. Great. Well, if we want to record the changes, let's add it. So git add, and then test.txt. So we'll type status again to see what changed. And you can see now it's green instead of red. And it says changes to be committed. So it's telling us, hey, I'm tracking this file, and now I'm ready for that commit. I'm ready for that checkpoint that you made. The technical word, again, is I staged the file for commit. Now we're going to make a commit message. Git commit, and then we're just going to hit enter. This is where it tells you to make the commit. If you do this by default, a lot of times it'll drop you into Vim. This is Vim. So if you don't know how to interact with this, I really recommend Googling it, because the first time you ever work with Vim is a pain. As somebody who uses Vim a lot and loves it, it is a pain to first learn it. I'll tell you the commands now that I'm typing, which should be all you need, but they're not intuitive. So in order to type in this, I'm going to press I, which will put me into insert mode. But the moral of the story is, I'm just going to type what I want my message for the commit to be, which should just be a quick description of what did I change, or what did I do. So in this case, I'll say added test.txt. Great. Then I'm going to hit this. These are just Vim commands again. Escape :WQ. W to save, Q to quit. And then I made my commit. So if I type git status again, you'll see that there's not anything there. That's because there haven't been any changes, and there's no new files that we aren't tracking. But if I type git log now, you'll see that there is a commit. This is called a commit hash. So a commit hash is just a unique string of letters and numbers that identifies a commit separately. A lot of times when people reference a commit, you actually only use the first 7 of them, which is usually unique enough. But if you want to be sure, just use the whole thing and copy paste. It'll see the author, who it's by, and the date and time that it was made, as well as what your commit message was. We're going to do this process again, but next time we're going to do it in GitHub Desktop. If we want to open this up, we're going to click this little add drop down and add an existing repository. Great, so we're going to choose, and I already had it ready to go. It's on the Git Workshop folder. You'll want to make sure your folder's selected, and I'm going to open that, and I'll add the repository. Great. It shows there's also no changes right now, and everything's hunky-dory. So let's change this to a 4. We're going to save it. In the same way, when you go back here, it'll say 1 file has changed. This 2 was removed, and this 4 was added. I forgot to show that command too. In command line, you can type git diff, and it will show you the same thing. So when you make some changes, you can type git diff and see what these changes are. Diff for difference. Going back, GitHub Desktop will show you the same thing. Now, if you want to add the file with GitHub Desktop, you check this box. This checkbox is kind of the equivalent of git add, but not exactly, because it doesn't run the add until you make the commit at the same time in GitHub Desktop. It's a similar thing. If you don't want it added in the commit, uncheck it. If you do, check it. Then we're going to add our commit message. Let's say changed line 2. And then we are going to make the commit. Great. Also, you can check history here, and you'll see what changed in that commit. Here's the first one, here's the second, and you can even see which commits. This is the equivalent of log, and this one will allow you to see what changed in that commit. The next step is we're going to kind of go back a little bit to the beginning of this process that I showed you, because when we type git init, that initializes a repository, but it doesn't put it to GitHub. If we wanted to push, which is that last important step I said, we could try that, but it'll tell us no configured push destination. It doesn't know where to go. So the first thing we're going to do is we're going to go over to GitHub. I have my thing, my GitHub account open. You're going to click this little new button, and it's going to ask to open a new repository. So we're not going to use a template. The owner's me, although if you have an organization, which I'll talk about later on, you can click which organization you want to own it. Repository name, I'll like Git Workshop. You can add a description if you want. Public or private. If you choose something to be private and it's part of an organization, it'll only be private to the organization, so anyone in it can view it. Then there's readmes and git ignores and licenses. I recommend having all 3 of these for every repository you make, but we're not going to start off with that. I'll talk about all of them more a little later. So I'm going to hit create repository now.
Does the repository name here have to match the folder name?
No, repository name does not have to match the folder name. Although if you do clone, right? Clone is where you copy another repository down, it will by default create the folder name matching, but the folder names do not have to match at all. So, if you were to create a new repository on the command line, it gives you the instructions here to pretty much do exactly what we just did. But we don't need to do that because we have an existing repository. So we're going to copy this remote add. And we're just going to copy paste these commands over. To go over what this command did, it was remote. Remember, remote's so far away. We're going to add a new one called origin, which is just how it's usually called by default. And here's the URL to it. You can see here, it's the URL. There's git branch-m.main, which we don't technically need, so I'm not going to run it, but it doesn't hurt to run it if you want to be careful. And then we're going to push -u origin main. From now on, whenever I call it after this first time, I only have to type git push. And you'll see that later when we do it again, but you only have to type the full thing the first time. Now, if I refresh this page, you'll see it showed up here. You can see test.txt is here. You can see the stuff in it. You can even see the history, just like you saw before with GitHub Desktop. You can click into one of them to see what changes happened during that commit, right? A lot of the things that are convenient are there. You can even browse what all of the files looked like at that time during history. There's only one of them, so it just kind of looks the same, but yeah. So now they're linked. So now whenever we type git push, it's fine. Now, if I was just on, a repository and I wanted to clone it, like I said, right? It would be this. I click this little code thing here, and then you can either pick the HTTPS, SSH, or GitHub CLI. You'll copy it to your clipboard, and you would type git clone, and then that. And that, when you hit enter, would clone it into your folder. It would just download it. I'm not going to do that because, I'm working on it right there. I recommend for SSH, you have to set up an SSH key with your GitHub account. I'm not going to go over that today. In some of the other resources I'll give you, they go through it. There's a lot of good tutorials for that online. HTTPS you can also use without setting anything up. And it'll allow you to download, but it won't allow you to push to GitHub. And that was changed a few years ago for security reasons. Even though it makes it harder, I actually really appreciate it from a security perspective. Now, if you were to use the CLI, when you create, you can download or clone just with this, or you can hit create new repository here. You can name it whatever you wanted, right? Choose where you want to put it, add the git ignore, add the license, add the readme, and when you go to create the repository, it'll even link it to the online for you. I don't personally use GitHub Desktop like this, but I really understand why people use it as a base level thing if you're just interacting with the Git repository for convenience purposes. It's a really nice tool. I'll give it credit. So that's how you actually set up and initialize and link your local to your remote, and also how you can do the same thing with GitHub Desktop. Let's go back to the presentation. Next step, ignoring files. We're going to go over a couple simpler things right now. Give your brain a little time to process what you just did. Ignoring files. Which kinds of files should you include or not include? Essentially, you want to include everything in GitHub, except if it's a really big file. Like if you have a couple photos in there, great, add them. If you have a lot of photos in there, or you have big videos in there, don't add those. As a matter of fact, GitHub's limit is 1 gigabyte, which is pretty generous, per repository. So you can't really put too much in there. In that case, you should be using, for big files, GitLFS or some other service like Box Account or something to back them up. I can cover that in the future if enough people are interested. You also shouldn't put in there things that your code generates. If your code generates some other, stuff in the meantime, like you have your data and you compress your data and you save it locally and then you act on that data for a convenience thing, right? You usually don't want to save the data that's the temporary data. It's usually takes up extra space. You can generate it again. Other people don't need that. If they care, they can generate it themselves, or your code will do it automatically, right? So you don't want to save that kind of thing. You can ignore those files or those folders. So let's quickly go over how to ignore a file. You open a file named .gitignore. If it doesn't exist, just make an empty file named that. Add the name of all the files or folders you want to ignore. And if you want to unignore a specific file, you put an exclamation point in front of it. So let's try it. We're going to make a new file. And I'm going to say ignore me. And I'm going to call it ignoreme.txt. Great. Now if we type git status, you'll see it's there and it's untracked. So now we're going to create a new file. And we're going to add ignoreme.txt to it. And we're going to save this one, though, as .gitignore. It's giving me a warning because the file starts with a dot, which means it's a hidden file. That doesn't mean there's anything wrong with it. That actually means it's correct. However, you'll notice that when I made it with VS Code, it added a .text at the end. It needs to not have a .text at the end. It needs to be just .gitignore. Now, when I type git status, you'll notice ignoreme.txt is no longer showing up, even as an untracked file. However, the gitignore is now there. So, we're going to put an exclamation point in front of it so you can see for a second. This would say you can not ignore, or don't ignore this file. And if we type git status, you'll see it show up again. If I remove the exclamation point, it's there, and it'll disappear again. So your initial question might be, why would I ever need that exclamation point? Because everything should be like there by default and being trying to add. And that's correct. However, there's certain situations where, say, you want to ignore a whole folder, except that one thing inside of it. So you could say you had another folder called my folder, and you wanted to ignore that, or you wanted to ignore everything inside of it, which is how you would say this. And then you wanted to unignore, thank you, ChatGPT, a specific file. You could do something like this and unignore that. I'll remove that for now. So git status. Now we're going to git add. If we want to just add everything, except for the ignored files, because it will never add ignored files by default. You can just type git add -all, --all, excuse me, and then we'll commit again. This is just something else I have in the little part that I showed, but it allows you just add a message without having to go into Vim like we did before. Added a git ignore. It's really important to have git commit messages that are good, because otherwise, going back later, you'll ask what the heck happened in each commit. It takes only a second to rack your brain for something that kind of describes it well, but it'll save you a lot of trouble later. And you never know when you'll need it, so it's good to just be in the habit of it. Now, if we type git log, we can see that there's 3 commits. However, this origin main is where it is online, and this is where we are locally. You should always get into a habit, always, I guess not always, but really try to push after you make commits. Because if you don't push after you make a commit, it's not on GitHub. It's not on your remote. If your laptop gets stolen or smashed or something happens, you poured coffee on your laptop, your work's gone. You never pushed it. So it's a good habit to push it too. So we have those. We have some changes. Wonderful. And that's how you ignore stuff. Moving on. Stashing changes. So sometimes you have some changes and you want to keep them in a separate place for a while because you decide you wanted to work on something else. Somebody asked the question last time, why would I want to do something like that? Well, suppose you're working on a quick feature, like, I don't know, you decide in an experiment to change one wording to a different wording, right? And as you were in the middle of that, somebody came back to you and said, I found a bug in your experiment. It needs to be fixed ASAP. The patient's running in an hour. Okay. I need to put those changes to the side for a while and go work on that bug fix now. So you're going to put those changes to the side for a while and you will use git stash. So git stash puts your changes in a separate spot. Then at any time you can git stash pop and it takes those // changes, removes it from the list of them, and puts it right back. You can see what stashes you've made with stash list. Oh, another example of when you might use this is, say you're developing a feature, right? And through the process, you're like, hey, I think I know a better way to go about this, but I don't think it'll work. I don't know. I just want to try it this other way, right? I might stash the changes I was doing for now, try it the other way, and if the other way doesn't work, then I'll remove those changes and go back to my stashed ones. It just helps me to, just do something quick. Git stash apply is another command. I labeled the first two in green because those are the two that you almost always use. The other ones are less commonly used. So git stash apply puts the last stash changes back, but keeps it in the list of changes. And git stash drop removes the last stash change. So git stash pop would be a combination of git stash apply and git stash drop. Now there's one more command that's not stash, but I need to tell you about, and it's git restore dot. This removes all uncommitted changes from the folder. So instead of stashing, you could get rid of them. The old command for this was git checkout dot. You can use either one, but just in case you see the other one online, git restore dot is rather new. You can do this, but just warning, when you remove those changes, they're gone. Like there's no recording them, there's no getting them back. If you do get restore dot or get checkout dot, they're gone. Those changes are gone forever. And so unless you're really sure you want to do that, it's usually better to git stash because you can always get them back if you need them or see what they were if you need them. But sometimes you should use git restore or git checkout dot because it's just the right thing to do. I'll just quickly show you this. I think you guys get the point quick. But say I changed this 3 to a 5, right? I'll type git status. I can type git diff. You see the change, right? But I don't actually want to add them or commit them. So we're going to stash them. You'll see up top the file changed back. You don't see it anymore. If I get stash list, you'll see there is a stash now. You can have multiple things, multiple stashes in it. And this is where git apply comes in handy, git stash apply, because sometimes you realize you stashed a few times and you actually want the stash a couple back. That's when that's useful. Now we tried our thing. We want to go back, type git stash pop, and you can see the change comes right back. Now we can make our commit. So git add -- all, git commit -m, changed line 3. And get into a good habit after you make a commit, push. I should also say on GitHub Desktop, there'll be a push button up here to allow you to push. I forgot to show that off before. There is an option to stash in Git Desktop. I'll change this to a 6. I have to remember where it is. Here we go. If you click this one changed file, you can right click that and hit stash all changes. This or discard all changes. This is the equivalent of stash. This is the equivalent of git restore dot. Great. You can also ignore this file if you have it there, or ignore all txt files. Those things are also in Git Desktop. So, I will git restore dot because I don't want to keep that change. So now it's gone and it's not anymore. Okay, so here's the features that you've all been waiting for. Going into the past, right? I'm going to say this again. I don't think I've said it enough, and I don't think I'll ever say it enough. Make sure you push first, especially when you go into the past, because this is where things start getting tricky. This is where things start getting screwed up. If you push, it's all in GitHub. No matter how screwed up you make it locally, you can just clone a new one. You can delete the folder on your computer and pull it down from GitHub again with clone, right? Git clone and grab it again, and you'll be back to where you were. Make sure you push first. Git log to see your history is a good way to start. And then you'll check out a commit. This allows you to temporarily go back to an old point in history. Git checkout main, if you run it after, allows you to go back to the future. So back to where you were before you ran that git checkout command. Now, this does not affect any untracked files. This is useful for debugging and seeing where things started to go wrong. You may need a git stash before using this command if you have changes, and don't forget to git stash pop when you go back to the future. And oftentimes I just use GitHub for doing this instead of actually running the git command, because if I'm just looking at code, a lot of times I'll just do that. That being said, the time when you would want and have to use this is if you wanted to run the old version of the code. Then you're going to have to check out that version. I can go show that really quickly. So if we have git log, we'll see our old history, right? Let's go back to the very beginning where we changed it. So I'm going to take this commit, right? I'm just going to grab the first 7 characters. We'll do git, checkout, and then that. You'll see we went all the way back to the very beginning. However, it's warning me down here that we're in this detached head state. Essentially, that just means we're not in a good spot to make commits. You shouldn't try making commits. Things are going to go wrong. I'll talk about this whole concept of branches in the next workshop, but I don't have time to go over that now, and they're much more useful when working with other people. But we can see what the old files used to look like. And if we wanted to run our code, we could run it exactly like it was before. Oh, also I should show, if I type git log, you'll see there's only one commit here. But if I type git status, it'll say our head is detached. So if you see this, you're not in a spot to be adding files or committing or pushing. Now we're going to git checkout main, and we're going to go back. You can see everything went back to the way it was, and that's just fine. If we type git log, we can see they're all back again. Now, one thing I should clarify is that before GitHub's main branch used to be called master. So if you look online, a lot of the examples we git checkout master. And if you use an old repository, you're going to need, every time I'm saying main now, you're going to need to use the word master. That got switched over a few years ago, so nowadays everyone just uses main. But I just want to give you that heads up that if you're seeing the old commands and you're like, why, I'm used to main, but it's saying master, what's the difference? They're just a different name for which one's the default. So like I said on this one, very often I said I use GitHub instead of just, checking out what it was that I need to with checkout. Because like I said before, you can go to commits, right? You can go back to added.test. You can see the changes in it. You can hit browse files. And there you go. You can see exactly what those files looked like at the time for every file in there. And then you don't need to mess around with your local one. It's just convenient to use it. I guess there's another benefit to GitHub, right? Is it provides this feature. You can also do /compare. And then if I say, let's say, 675 BEC6 ... The dot just means 2. So I'm copying this number because I want to see what changed between this one and, let's say, this one. B03293C. I can see all the different changes that were made. I can see the difference between test.txt. I removed the 2 in line 2 and added a 4 there. And I added this file.getIgnore. So this is just really convenient. You don't need to mess around with anything in your local. Now we're going to go to undoing the present. So the first and easy way to do this, and the safest way, is called git revert. You can call git revert. There's this head squiggly and then an N, which is a number of commits to undo, and then a ... saying to do all of the ones before that. Or if you just want to go back one, you can just squiggly that one. Or if you want to do a commit specific, you can just, instead of head squiggly N ... just put the specific commit. This makes a commit for every commit you are trying to undo. If you git revert -head n squiggly ... this little -n flag, it'll undo the changes, but it won't make all those commits. So say you want to undo like 5 things, instead of it making 5 more commits, you're gonna revert and it'll just have the changes, and then you can make your own commit. You can undo the undo with the same exact command. So if you were to revert and then you want to revert again, you can just call revert once and it will just keep adding more commits. This can make your history look sloppy, which you probably don't care much about at first. Or even later. A lot of times we'll just do this instead. It's safer, and that matters a lot. So let's go try this out. So if we type git log, right, we can see changed line 3. Let's revert this one. So we'll type git revert, and then we're just going to copy these again. Or we'll just copy the whole thing, because I don't know where 7 is, and I'm having trouble counting. So it's going to ask us now to just, make that commit. And if we wanted to change what it said here, we could say, but usually you just keep that the same because it makes it pretty clear. And we'll save, and you can see it undid it. Now if we type git log, it'll say we reverted. Now, okay, let's revert the revert, right? So, a specific commit. I'm going to go back in time. You can ignore this command for now. It's kind of a little bit of hint of what's coming up in the next slide if you follow along. But I'm not going to demo what's happening in the next slide. So I'm just going to tell you about it. But you can see what's going to happen here. Great. So I'm not going to explain all the magic that happened there, but you can see I went back in time, so the reverts aren't there. We'll just give an example of a time we want to go back, a few of them. It revert head squiggly 2. We're going to go back into the past, or we're going to revert. We're not going to go back into the past, and then we're going to save. And it's going to ask me for each one I want to go back and to undo. So you can see now I undid the change for line 3, and I undid the change for the git ignore. Because as I go down, those are what we did in order. We added the git ignore, we changed line 3, so it does them in reverse order. It reverts that, and it undoes that. Let's see if that works again. So I'll revert the revert, and now it says reapply, git ignore. Yep. And reapply, changed line 3. Perfect. And now if we do git log, you can see that it reapplied this same change, and it reapplied, and now we're back in the same spot. You could see the files were changing as we edited them.
If you wanted to revert the first one, would you put a 0 instead of a 1? Head squiggly line 0.
You are correct.
Okay.
Yep. And then we can do that again to put it back. On GitHub Desktop, we can do the same thing. We can see a lot of history here. Like I said, it can make your history a little messy, but most of the time you're not going to be reverting, reapplying, reverting the reapply, and then reapplying the reapply. Like, you're not going to be doing all that. But if you wanted to do that, you could just select one, and you can hit revert changes and commit with the Git desktop. Does everyone understand that? Because this is like the key feature, is you can revert. You can either git revert with a specific commit number, which it doesn't have to be the first one, like that, or you can git revert with head, squiggly, and the number commits you want to go back, where 0 is the most recent, 1 is after that, or with the number that you want to do, as long as the dot dot is after. So git revert head squiggly 2, and then the dot dots.
If you had a commit like 3 commits ago, and you decided you wanted to revert the stuff you did there, but you had changed some of those changes that had been made in that commit, will it just change the bits that haven't been changed and leave everything else, or does it get a bit dicey?
It gets a little dicey.
Okay.
And I can show you. I'll do a simple example, right? So last thing I changed was line 3. The next thing I'll change is line 1. Let's change this to 6, right? Okay. I'll make a commit, git add, dot text, commit dash m, changed line 1. I'll change line 3. Git add dash shell, git commit dash m, changed line 3 again. Now I'm going to revert the original changed line 3, and you'll see what happens real quick. This is called a merge conflict. You usually don't get into this unless you're reverting something from the past, not that immediately happened, or when you're working with multiple people. But essentially what this is saying is, this is the head, this is what you are currently at. Remember how we just changed it to 7? Then it'll put a bunch of equal signs, and then it'll say, here's what you're trying to do new. All you have to do is keep the thing you want to keep and erase the lines you don't want to keep. And you save the file again, and you add that file back. Git add. Forgot. And if you type git status, you can create your new commit. Reverted. And now when we type git log, it allowed you to revert. It just made you figure out what you needed to do, though, because it couldn't figure it out for you. It didn't know which one you wanted, so it made you pick. So that's the big one. Undoing the present option 2. We're going to go through this real quick. It's that git reset command you saw me doing. This rolls back your local repo back to a previous commit, and it actually changes the history. This removes all commits after the one you chose, but keeps the changes locally. Git reset head at $1 undoes that first reset if you want to do the same thing as the git revert and then revert the revert. That gets even harder if you see git reset and you see a -- hard on it. Really be careful before running that command. It doesn't remove any current changes, though, which can be confusing, so use git stash. And if you want more info about git reset and all of its nuances, here are some 2 links for it to help. After you do git reset, you'll have to do git restore or git checkout with the dot after it to remove those changes. And then you're going to run your first dangerous command, which is git push -- force. make sure you really want to do it before you run that command, because it overwrites your online history with your current history. So every other time I was telling you, right, if worst comes to worst, you can delete the local thing and just re-download again. However, that's not possible if you do this, because you're actually changing the online. It is possible to undo it if you have the local computer, but now it's again getting really tricky and you lost your backup. I'll quickly show you this. So I'm going to git push everything with all those changes. Now I'm going to git log. I want to go back all the way to before I did all these reverts. And I'm going to git reset all the way back to there. If you check the log, you see all of those other histories are gone. I'm starting to edit my history. And we'll do that git restore dot, and all those changes went away in the files and everything. They're gone. But it's only gone locally. If I go to GitHub and I go to my code and I go to my commits, you can see there's 13 of them. There's a lot of them. Now, if I try to git push, it's going to yell at me and say, you can't.
What was the git restore bit for?
So when you get reset, it keeps the changes, but removes the commits. Yeah, you can see here how it was modified. So if I type get status, it would have been there in red. And then when you do the git restore, it removes those changes. It just wipes them out. So then, but it doesn't let me push, because it's saying, hey, the history on GitHub and your history locally, they don't match. And how if you look up online, you'll be like, oh God, I got this command. What do I need, right? Or you ask ChatGPT, what command do I need? And it'll be like, oh, run git push -- force. But it won't tell you why that's a bad idea, because when you do that, it changes your online history. Your backup's gone, or your backup's changed. So that's a risky command. Know what you're doing. And unless you really care about how your history looks, revert's the better command. We're going to go on, that's the meat and potatoes. Now we're going to go on to a lot easier stuff. Tags and releases. There are certain times you want to mark a specific commit as important, so we quote unquote tag the commit. A tag can be anything, for example, my special commit or whatever you want to name it. Usually it's a version number, like v3.2.1. This is what the command will look like. Git tag -a, whatever you want the name of your tag to be, -m, and the message you want to go with it. Usually you just kind of say why that commit is special or important with it. Make sure the version number in the tag matches the version number in your task, which should be logged. You should be logging the version number in your task. What I mean by that is, like, if you have an experiment and you're running that with a patient, right? Whenever you run on a patient, it should have a version number with it. And the things that you're doing with the patient, you normally record stuff, you log out, right? Log the version number of your task with that information from the patient run. It allows you to go back to the code and figure out which version of the code you were using. As you can see in the bottom bullet point, it's not as important in analysis code. You might want to tag for publications if you plan to release the code publicly, but this is a lot more important for like experiments themselves. So let's go over an example. Say you want to run a task or an experiment on a patient, and you're marking that specific commit so you can come back and check out how it worked for that patient, and that can be really important, like I said. I recommend every version that you run on the patient be tagged with a new version number, and make sure you have a matching version number in the task too to what you tagged. That's another mistake you could make, and I have. And I usually always save that commit hash, that number with it, just in case. Here's the Python code to do that. If you're using C#, or Unity, I created a utility called SciForge that helps you develop psychology and neuroscience experiments. It does this automatically. In case you want to re-implement it yourself, or you just don't want to use SciForge, I even linked the code for the C# code to do that yourself. Let's quickly talk about semantic versioning, or that whole version number you saw. So semantic versioning is the name of the industry agreed upon versioning system for pretty much all programmers. So let's look at this is most complicated name I could come up with, 2.1.0-beta.1. And we're going to break this down, and most things will not be this long. There are 3 parts to the main version number. 2 is called the major version, and it's incremented when you have a breaking change. So for example, you add a new phase to the task, right? It totally changes your task paradigm a bit. That's a major version change. The 1 is a minor version change. It's incremented when you add new functionality or you change some minor things. For example, you add a new sync box. For those of you who don't know what a sync box is just an external piece of hardware that allows you to handle timing between multiple machines, right? That's kind of a feature. It doesn't change how your task works. You'd iterate the minor version. The last one, the 0, is called a patch version. It's incremented for small bug fixes, like if you realize there was a typo in a sentence, right? That's not a huge phase change. It's not even like a new feature that's like kind of cool. It's just like a really minor thing. That's a patch change. Now the beta.1 is the pre-release version. It's used to indicate how far along something is. Most of the time you won't even be using this. The number next to the beta is incremented with every new beta version. There are 3 normal pre-release options: alpha, beta, and release. Alpha means the code has some features, but every intended feature has not been completed yet. Beta means that every intended feature, like everything you planned, has been implemented, but you haven't debugged everything yet. And then release means the code is ready to go. For example, it's ready to run on a subject or a patient, but this is often omitted. Usually you just don't even include the release. So 2.1.0-release just becomes 2.1.0. If you're going to have multiple releases for some small change, you'd usually just change the patch number. The only other time I use this really is if I'm doing like beta changes. So for example, I have a task that I think is ready to go, right? But I want to, before I run it on the patient, I want to give it to some people in the lab to test out. I'll name it like beta.1 and give it to the lab member to test out. And if they find changes, right, I'll call it beta.2. And I'll fix those bugs until it's ready to run on the patient. And then I just remove that and call it the release version. That's beneficial as well, so that you can kind of have one that's nearly ready to go, but you're not confused about which one got run on the patient. And your lab members can also know if something's marked beta, don't run it on a patient unless they have like explicit permission. And the next thing we'll talk about is releases. Releases are a GitHub specific thing. They kind of do the same thing as tags do, but they provide you with 2 extra features. They provide a zip file of the code at that point in time, and they provide a convenient way to make visible notes for that tag. I use all release tags to record what changes an analyst would need to know when comparing a version against the prior version. To show you an example of that, we'll look at the releases for SciForge itself. So you can see here's the initial beta release, or the initial release. Then we have v1.1. It has general and some new features. Like I said, in actual experiment code, I usually have another section called things analysts have to care about. And like I'll have things like what changed in the log files, etc. It's convenient for them when they want to quickly look through and be like, when was that one thing changed? And then they have the version number, and then they know exactly where to look at their experiments between. Sometimes it's better to just do it in the analysis itself, but sometimes it's really nice to go back and do it this way. For example of when it's nicer to do it this way is, say, a picture changed, right? Going back and looking to see when the picture changed in the code or with these release numbers is a lot easier than trying to figure that out via some analysis code. It might not even be possible with the analysis code. Oh, I should show you how to make a release quickly. So if you're in releases here, you just click draft a new release, and then you choose which tag you want, and you make a title for it. Add some more descriptions to it, just like I did, and hit publish. That's the whole process. It's nice and easy.
So the tags just get like a commit message length message associated.
Tag usually get a commit message length message, yeah. So when you tag, you do it locally. So it'd be get tag -a v3.2.1 -m initial release, right? Or something like that. Just a short thing with it. Usually, if I have any more notes, I'll add them in the release information on GitHub. I believe you can also go here and create a tag. if you want to just click and do it that way. So now we're going to go on to some just general tips. Make every commit every time you finish a feature, or if it's part of a feature that's like a big one. The more you commit, the more often and more easy it is to roll back to a point you knew. If you make an error or you screw up, you don't need to make, that copy of that folder and call it V2 and then go back to it, etc. And the more often you make the commit, easier it is for you. But try and make sure your project is in a working state when you commit. It doesn't have to be, especially if you're working on it alone, but it just makes your life easier a lot of times. Each repo should have a README and a license. If your README gets too big, make a documentation folder and then just put more files in that documentation folder. Tag your important commits. It's pretty easy. It's one line, makes your life easier. Write descriptive commit messages. Like I said, it takes you like another, 20 seconds to come up with a descriptive commit message, and it saves you a lot of time when you're looking back in your history, which you never know when you'll have to do. Try not to upload sensitive data like passwords and MRI data, please. As a matter of fact, please don't even put it in the same folder as your GitHub repo. It does happen. Try to solve it as quickly as possible, especially with MRI data or something like that, where it's PHI or PII. Don't upload anything like that to GitHub. Even if it's in a private repository, GitHub still has access. Don't do it. It's good to review your code with git diff before committing. It allows you to just quickly see what changed. This is helpful if you changed a lot of files and you only want to see what happened, or if you're trying to come up with that commit message, you can type git diff and quickly see like, oh yeah, right, that's what I changed, right? Or if you're just using the GitHub CLI, you'll immediately just be able to see it here in your changes. Save your environment to your repo if you're using Python analysis. If you're using Conda, that means using Conda export or Conda export -- from history, or there's other tools online that are even better than those. If you're using pip, upload your requirements.txt file. It makes your life a lot easier when you have to go back and regenerate that, especially if you need to run it years later and everything moved on, because Python, everything changes every 6 months. It really helps if you're somebody else trying to run your analysis. Like, having that there makes it possible in the first place a lot of times. So how to organize a lab GitHub. I recommend making an organization for your lab, GitHub organization. Just like this is here, Brusca Tech is an organization. You can make a different repo for each task within reason. Documentation that's specific to like a task or analysis should go with the task or analysis. Documentation that uses multiple resources of a lab should go in a lab wiki. It's better that way because if you have a specific task, then you always know where to find it. It's right in the repo. But if you're using multiple resources, then you're going to be questioning which repo it's supposed to be in, etc. Things you don't need unless you have a big lab or a complex situation. Organization teams in GitHub to control specific permissions for different groups of people. Again, useful if you have a complex situation or a big lab. And then pull requests to handle multiple people contributing and you have something to review the situation. I'm not even going to go over pull requests are until the next presentation, but they're probably not needed unless your lab is bigger. So what commands are risky? Git push -- force, like I said, if there's the -f or a force option, be careful. That -- hard at the end of git reset is very risky. It removes it all locally. It's not as risky as -- force or push -- force because that removes the stuff on the server. Git clean -fd permanently removes the files that are not under version control. So if you added a file, right, and it's not being checked by version control, this will remove it. Again, you see a -f in there, so be careful with that, because there's no getting that back. Git wasn't tracking it. And if you see the phrases git rebase or git filter branch, look out. Those are also risky. I'll cover what those are in the next presentation, but those start editing history, and that's almost always risky. Git for Jupyter notebooks. I recommend you install NBDime. I'll go into this more in the next presentation because it'll make a difference, but you just pip install this and then git config enable. It will make dealing with Git for Jupyter notebooks 100 times better. It'll make it readable, so it's possible. I really recommend doing this if you use Jupyter notebooks at all. And then here's some more info and a quick overview of me. Pruska Technologies, my company, helps to develop experiments for different laboratories. I also made SciForge, which allows you to easily create neuroscience and psychology experiments and handle all the stuff you don't normally want to do about it. I'll help integrate hardware like EEG, IEG, eye tracking. I'll help optimize analyses, teach programming or tooling concepts just like I'm doing now, or help to hire new researchers and programmers, because it turns out it's actually really hard to hire a programmer if you don't know what a good programmer should be looking for, or junior programmers, etc. So I'll help with that process as well. Because I know a lot of times if a psychology lab needs a programmer, what they need them for is some short-term, like 1 to 2 month thing, build me a task, right? And then they're like, I don't want you anymore. I don't need you anymore. And matter of fact, I can't afford you anymore on a payroll for an actual programmer. So that's kind of what I provide. I can come in and help as needed, but sometimes also you need somebody more full staff, and that's not what my role is going to be. So I'll help you hire for that as well. If you made it this far in the presentation, thank you so much for watching. I hope this was helpful, and I hope you have a great day.